Only mode.
Hello everybody and welcome to today's webinar. Thank you so much for joining us today. Thank you as always for those of you that logged in early. I hope you had a chance to check out the advertisement we've got on the screen here, which is for Oaktable World. This is a conference that's going on in San Francisco, September 23rd and 24th, right next door to Oracle Open World, and actually Kyle, Hailey and myself, we will be going over this same talk there on the Monday at 4 p.m. So if you're based in San Francisco or you're going to Oracle Open World already, please do check out Oaktable World. You can find out more information and you can register for the conference at kylehaley.com/Oaktable World. It'd be great for you to come and join us or at least pop in and say hello. Okay, so today's webinar is on how to enable risk-free database experiments. Today's presenters, the main presenter today is Kyle Hailey. If you're on Twitter, please follow Kyle at Kyle H. Hailey. Kyle's a technical evangelist at Delphix, an Oracle ace and a member of the Oaktable. For those of you that come to the Redgate webinars regularly, you'll know me. I'm James Murta. You can follow me at All Things Oracle. I work in the Oracle Tools team at Redgate Software, and I'm the creator and editor of allthingsoracle.com. So just a few things before we get started. Everybody will be on mute for the duration of the event. If at any time you can't hear me or if my sound goes a bit strange, again, those of you that come to regular sessions will know that we've encountered a few sound issues in the past. Please do let us know using the questions panel or the chat box. Obviously, just make sure you check your own audio settings first, particularly if our sound goes. There's quite a lot of us on the line at the moment, so there may be a few little sort of intermittent sound issues, particularly with the large number of people that are here. There will be a Q&A session at the end, but please feel free to type your questions in the question box in advance. We're going to go over quite a lot of stuff today. Hopefully this is going to make you think and get you thinking as we go through the session, so make sure you do put the questions in advance as well. This session is being recorded, and as always, I'll try and get it up online within a sort of a day or so, but I'll certainly email you all when the session is available. So Kyle's on the line already, so I'm just going to hand over to Kyle to talk a little bit about Delphix.
Hi, welcome everybody. My name's Kyle Hailey. I work for Delphix, and Delphix is a company that was founded in 2008, and we launched our product in 2010. Our CEO is Jed Yue. He's also the founder of Avamar, a $1 billion revenue company that he sold to EMC. Delphix is based in Silicon Valley. We have global operations. 10% of the Fortune 500 are already using Delphix. It's becoming the de facto standard for database virtualization, and Delphix is growing at almost 300% a year. So we have quite an impressive list of customers around the world. Dutch Bank, Facebook, IBM. You might recognize some of these logos. So I'm excited to talk to you today about the technology and how it can accelerate development.
Thanks, Carl. So some of you may have heard about Redgate as well. So Redgate's been around for about 13 years now, or actually 14 years the next month. So over 600,000 professionals worldwide use Redgate software, including 93 of the Fortune 100 companies. Like Delphix, there's lots of familiar companies here that are using Redgate's software. Our philosophy has always been to design highly usable, reliable tools. We like to try and make complex problems simple through our tool, and we're looking to solve the problems that are commonly faced by DBAs and developers. Through this session, we're going to see some of the Redgate tools which make up the deployment suite for Oracle, in particular source control for Oracle and schema compare for Oracle. If you want to find out more about the Redgate tools after today's session, then just simply go to redgate.com/Oracle, and there's lots of information there. So I'm going to pass over to Kyle now. I'm going to hand the screen over, so please bear with us if there's any little technical delay or anything. And Carl's going to go through the first part of his presentation and just really set the scene about what we're going to show that our tools can do afterwards. This topic is on how to enable risk-free database experiments. I'm going to pass over to Carl Hailey now.
Hi, James. Is that showing up correctly?
That's great, Carl. Thank you. I'll leave it with you now.
Hi, everybody. Just a quick overview of what we want to go over today. I'm going to spend about 20 minutes talking about Delphix and some of the problems that we've seen in the industry, and we'll talk about solutions to those problems. And then we'll go into how Redgate also addresses these problems and the solutions. And finally, we'll do a live demo using Delphix and Redgate to address these situations. So some of you might be familiar with this cycle that we've seen in the industry. I hear about it quite a lot, where IT department budgets are being constrained. And when IT budgets are constrained, one of the first targets that we hear about trying to be reduced is storage. But as storage budgets are reduced, of course, the ability to provision development environments to allocate database copies for those development environments goes down. And as the development environments become constrained, of course, development projects start to hit delays. And as those projects are delayed, the applications that the business depends on to generate revenue to actually pay for those IT budgets becomes delayed. So with this reduced revenue, the business has a harder time paying for those IT budgets, which in turn puts more pressure on IT. So it becomes a bit of a vicious circle. And some of you might have heard the saying in the industry, we want good, fast, and cheap. Choose two. So the idea is, this means that we want to create good applications, we want to create them cheaply, and we want to create them fast. But we can't have all three. And the saying goes, we have to pick two, which creates some problems. And at Delphix, here's some of the things that we see in the industry. I don't know if these situations ring a bell at your organization or if you can imagine some of these situations. But here are the issues that we at Delphix are seeing in the industry with companies that we're talking to. We're seeing inefficient QA, which is causing higher cost of QA. We're seeing QA delays, and these delays in getting QA work completed causes greater rework of code problems that are found. We see issues with sharing database environments, and because they're shared, it creates bottlenecks in developer productivity. We see situations where development teams are using database subsets, and because they're using database subsets, this causes more bugs that make it into production. And finally, we're seeing slow environment builds or creation of environments for developers. And of course, this slowdown causes delays in development projects. So let's look at these 5 points in just a little bit more detail. So the first one here is inefficient QA or long build times. We talked to one of the companies that we've talked to is Presbyterian Healthcare, and they told us that they spend 96% of their QA cycle time actually building the QA environment, and only 4% of the time actually running the QA suite. And this happens for every QA suite, meaning that for every dollar spent on QA, there's only 4 cents of an actual QA value, meaning that 96% of that cost is spent on infrastructure, time, and overhead. And because the time required to set up QA environments can take a while, the actual QA suites tend to lag behind the released code. So if I'm finishing a sprint or a code freeze, there's often a delay before that code actually gets run through a QA suite. And the longer the time that goes by between when code is frozen and when the QA suite is run, the longer the time it takes to find bugs in the code. And the longer time it takes to find bugs in the code, the more dependent code is written on top of that bug, meaning it becomes more expensive to roll back any dependent code. In his seminal book, Software Engineering Economics, that some of you may be familiar with, author Barry Boehm introduced the computer world to the idea that the longer it takes to fix a bug, or the longer the delay in fixing a bug, the higher the costs are to correct it, and that these costs actually rise exponentially the longer it takes to fix a bug in the development life cycle. The third thing we see is development teams using a single copy of a production database, and they share this copy across all developers, and this causes bottlenecks. So I'm not sure if you run into this, but I have personal experience. When I was talking to a group at eBay, that development group used a single copy of the production database between the developers on that team. And what this sharing of a single copy of production meant is that whenever a developer wanted to change or modify that database, they had to submit their code changes to code review. And that code review took 1 to 2 weeks. And I don't know about you, but this would drive me crazy. As a developer, this would really impact my motivation. And I had direct experience with this kind of disgruntled developer situation. When I was last at DBA, all the development schema changes went through me. And I had other work to do, and I generally handled them very quickly, but it might take a half a day before I processed the schema changes. But this delay actually caused a lot of discontent in the development team. And because of that discontent, the development team actually restructured the whole schema of the database and created something what's called in the industry an EAV schema, or entity attribute value. This is sort of the forerunner of the NoSQL databases. It's where fields are rows in a table. So to pull out an actual row, a logical row requires pulling out many rows from a table to build up the record. And what this means is that the code, the SQL code, becomes unreadable and performance becomes atrocious. So these bottlenecks create a lot of frustration on the development teams. And not only does it create frustration on the development teams, but because so many people depend on this large database, and this large database takes a long time to refresh, and everybody has to be coordinated to actually do the refresh, usually refreshes don't happen very often, which means the data in these databases becomes old and unrepresentative of what's actually happening in production. So one of the ways to get around this problem of sharing a single copy is creating subsets. In this way, we can give a subset to every developer. One of the companies that we talked to, Royal Bank of Scotland, says they spend 50% of their DBA time actually creating copies. And they can't create full copies because they don't have the resources. So they create subsets. But these subsets themselves are time consuming. The scripts have to be maintained to extract data from the production database, make sure the data is coherent, make sure that referential integrity is respected, and these scripts are constantly breaking, requiring maintenance. And now what happens, I don't know if you guys have run into this, but what happens when code written on subsets actually makes it into production? It actually, in many cases, hits the wall. This is what we're finding with customers. One customer we talked to, StubHub, which is a subsidiary of eBay, estimates that 20% of their production bugs arise because they're using subsets in development. Now there are a couple of reasons that can happen. One obvious reason is the data sizes in production are massively larger than the subsets. So queries that ran fine on the subsets hit performance walls when they get into production. Also, the data in subsets might not be fully representative of the data in production, and code runs into anomalies when it hits new types of data in the production database. And then finally what we see, and this is probably the biggest and most pervasive problem of all, is slow build times. So when we want to build a development environment, the long pole in that build process is allocating the database that this application code will be written on top of. So first of all, this is going to take a lot of administrative steps and bureaucracy. The developer or development team has to submit a request to management. Management has to decide whether to approve this or not. If it's approved, it goes to DBA. The DBA has to coordinate with system admin for machine resources, and the systems admins have to coordinate with storage admins to allocate enough storage sufficient for these databases. Many of the customers we talked to tell us that this takes as long as 3 to 6 months to deliver a development environment. And because it takes so long to deliver these environments, developers come to know that it's not even worth asking for a copy of a database. It creates a culture of no, and developers just give up and don't even ask for copies. If they need to write custom code for a project and they need a copy, they don't even ask, they just give up. Or maybe there's an anomaly on the production database that needs to be investigated with a copy of the production database. It's not even worth trying to ask for that copy because it's not going to happen. And it demotivates developers. So just a review of what we saw. We see inefficient QA driving up cost of QA. We see QA delays, which increases the amount of rework of code because of bugs that code's written on top of. We see sharing databases causing bottlenecks in development teams. We see using subsets of databases causing bugs that hit production. And we see slow build environments creating delays in the development projects. So CIO Magazine did a survey, and they found recently that 60% of projects, IT projects, are over schedule and over budget. And the trick here is getting the right data to the right people at the right time. So the problem here is data. Data is the problem. But we can solve this data problem today with Delphix. Delphix can unlock your data, getting to the right people at the right time. The idea is actually fairly simple. If I have multiple copies or multiple clones of a database, across those copies of the same database, 99% of the blocks in those databases are going to be identical. Each clone will modify a small amount of that database, and otherwise those blocks could be shared. And if we change the architecture to actually share the duplicate blocks and keep the modified blocks private to the clones, we can save not only a lot of storage, but more importantly, we can accelerate the development environment build process. And this is where Delphix comes in. And this is analogous to VMware, where VMware took a single set of hardware and allocates multiple virtual machines. Delphix takes a single set of data files along with the change stream for that database and allocates multiple clone copies of the database, making the quickest clone, not a clone where we have to copy any data, but a clone where we don't move any data. We just point a new target machine to the shared data files, and there's no data movement. So if I was doing physical copies, I'd have my host machines running the database instances hooked up to a SAN or storage array, and each of those would have their own physical copies of the database. Now, in the virtualized world, where we use Delphix, those host machines running the database instances talk to Delphix, which looks just like a NAS storage array. And Delphix orchestrates access to a single set of data files on the storage array, and any blocks that are modified by those clones are orchestrated by Delphix to only be visible to those clones that actually change the data block. And this currently works with SQL Server and Oracle, and Delphix is expanding the service to Postgres, MySQL, and Sybase. So what is Delphix? Delphix is just software. It fits on a USB stick. It installs on any commodity x86 hardware. It supports Oracle 9.2 through 12c, Standard Edition, Enterprise Edition, Single Instance, Rack, and it supports it on AIX, Spark, HPUX, Linux, and it supports SQL Server. So the first thing we do is we install the Delphix software onto commodity Intel hardware. Delphix installs as a virtual machine. It takes about 5 minutes to install. Once it's installed, we allocate storage to Delphix. Delphix can use any kind of storage. It could be MC, NetApp, Fujitsu, JBOD. And one of the cool things, one of the awesome things is, in this current economy where flash storage is becoming a viable option, and there's a lot of flash storage players in the marketplace, and it's unclear who the winner is going to be, Delphix can run on any of those storage solutions, whether it's Violin, Pure Storage, or Fusion IO. So Delphix gives one the freedom to use this cloning method, database virtualization, on any kind of storage. So once we install Delphix on commodity hardware, allocate storage to Delphix, we then register a source machine with Delphix. So the source machine is running a source database, typically a production database. Once we register that machine, Delphix will auto-discover any databases on that machine, and at that point, we can pick one of those databases, one or more, and link to them. Now, at link time, which only happens once for the life of that database in Delphix, we take a full copy of that database and put it onto Delphix. That full copy is typically compressed by 1/3 the size. And then after that initial one-time only link, Delphix collects incrementally and forever changes from that source database. And we say this in a time window. And any data older than the time window is purged. This time window is typically several weeks wide, meaning I can create clones anytime from within that time window. So typical architecture that we see at companies right now when we come in is we have a production database and then multiple copies of that production database in development teams, QA teams, user acceptance teams. Each of these are full copies of the database, which take a long time to create and take up a lot of storage. With Delphix, we come in, we have one copy of that source database compressed onto Delphix, along with its change stream, and then all those teams share that single set of data files for their clone databases. And the UI is simple, slick, and easy to use. I think it's sort of fun because one of our customers said the Delphix UI is what Enterprise Manager at Oracle would have looked like had Apple designed it. And I'm quite a fan of graphics and user interfaces, so that was a fun compliment to hear. Now, in Delphix, there are three core parts that I want to emphasize. The first one is the source syncing. So we link to a source database, and not only do we link to it, but we collect continually and forever the change stream on that source database. And that's brought into Delphix, where we have DXFS, or the Delphix file system. Now this Delphix file system is capable of taking unlimited instantaneous snapshots, and it's storage agnostic. It'll do the snapshotting in any kind of storage. It has compression, typically by 1/3, and that compression is uniquely on data block boundaries, making it very efficient. The overhead for doing this kind of compression and decompression is practically undetectable. And one thing that's unique in the industry is not only do we share the blocks on disk, but when those blocks are read into the memory in Delphix, they're shared by all the clones. So if there's multiple clones of the same database running on Delphix, once one clone caches the data blocks in the Delphix server, all the clones have access to those data blocks in memory. And the final third part is provisioning of virtual databases. All this is handled automatically. It only takes 4 clicks in the graphic interface, and Delphix will automatically manage sharing those data files over NFS to the target machine running the instance. Delphix will take care of all the NFS mount parameters, of the SID init.org parameters, of changing the database name, of starting the database, recovering the database, registering it with the listener. All that's handled automatically so that anyone, a junior DBA or developer, can provision their own virtual database clone copies. And what this gives us is access to fast, fresh, full database clones. So they're fast. Creating a clone only takes a couple of minutes. The fastest clone is a clone that doesn't require any copying. There's no data movement. We just start up an instance on a target machine and point it at those shared data files on Delphix. It's fresh data. It can be provisioned within a few minutes from the production database. And these are full copies of the database. And what this allows us to do is, since they're almost free, since there's almost no storage overhead for these virtual databases, we can allocate as many as we want, meaning we can go from sharing a single database across developers in a team to actually giving every developer their own copy of the database. And one of the unique features and super powerful features in this is we can branch clones. So if the development team is working on a database and making changes in it, and they freeze their code, and they're ready for it to be QA'd, no longer does QA need to build a QA development database. they can actually just branch it from the virtual database used by development. And this only takes a few minutes, and then QA can immediately start running their QA suites. And the interface is so easy that it can be self-serve. No longer do we have to depend on DBAs, system admins, and storage admins, but developers can allocate their own virtual database clone copies in minutes themselves. So what we've seen with Delphix is now QA becomes efficient. It's low cost, high utilization. We see quick QA, where when there's the end of a sprint or a code freeze, the QA suites can be immediately run within minutes after the freeze. We see where every developer gets a copy of a database, which parallelizes the work by developers. We see full databases being used by development, which means less bugs hit production. And we see fast builds, which creates a cultural yes and increases and accelerates the development. So just going over the situations that we saw in the beginning, QA is efficient. No longer do we spend a long time building the QA environments, but QA environments are built in minutes, meaning that there's high efficiency in the QA teams. No longer do we see slow delays and lags in the QA suites, but QA suites that are run immediately after code freeze or a sprint, meaning there's less dependent code written on top of any bugs. Those bugs can be addressed quickly, which means less rework of the code. No longer do developers have to share a single full copy of a database, but they can all get their own private copies, which means that the development work becomes parallel. Not only does development work become parallel, but because it's easy to create virtual copies, QA teams can now run QA suites in parallel. We see full-size databases, which means that code in development is written on a full-size database, which eliminates bugs that would otherwise make it into production. For example, we talked to StubHub. StubHub estimated that using Delphix, they had a 20% reduction in bugs that made it to production. And then we see self-service, which means fast, efficient provisioning of databases, which means a cultural yes. If anomaly happens on production, a developer can spin up a copy in minutes and investigate what was happening. If a developer needs to do some customized coding, he doesn't have to go through weeks of delays trying to get a copy of production. He can spin up a copy and start developing that customized code immediately. So just some of the things we've seen with Delphix. For example, we talked to Macy's. When Macy's went to Delphix, they went from 4,000 hours a year of cloning, of DBA cloning time, down to 8 hours a year done by a junior DBA. Hailey 10 Core over doubled their project outputs. And this is like taking their 100-person team and making a 200-person team. It's incredible value. Health Dialog reduced their storage from 720 terabytes down to 8 terabytes. So now, James, I'm going to pass it back to you. We'll talk about how Redgate dovetails into this utilization of virtual databases.
Thank you, Carl. I'm sure everybody will agree that the opportunities with Delphix are very exciting. The idea of spinning up loads of databases very quickly is hugely exciting, particularly if you're in an organization where you're looking to experiment a bit more on the database, enable people to make changes rapidly. What Redgate... Sorry, Carl.
I just throw it in there. It's extremely liberating. I mean, things that I would never consider doing as a developer, or even a DBA. Now I can just spin up a copy, run my test, and throw it away. It's extremely liberating. It opens up all sorts of possibilities.
Yeah, absolutely. So where Redgate fits into this is the Redgate tools enable you to deploy changes amongst all of these databases very quickly, very easily. More importantly, though, we help to reduce the errors when you're doing. As you can imagine, if you're deploying more often, there are more opportunities for errors to come into this process. Apologies, I do actually need to take the screen back so I can control the PowerPoint here. So one of the things that we believe really strongly in reducing errors, particularly when it comes to deployment, and especially when you've got multiple people with their own copy of the database and they're making changes, is to put source control at the heart of development. And source control can help reduce deployment errors. It enables everybody to see who changed what, why, and when, and it gives some context to the development of the database. So this is great, so we don't just end up with a new copy of the database, a new version of the database, which is almost blind. With source control, or by source controlling your changes as you go along, enable you to build up a story of how the database ended up in this new state. I'm just going to show a quick screenshot here of source control for Oracle. When we go through the live demonstration, obviously you're going to be able to look at this tool in a little more detail. I'm going to dive into some of the features, but I just wanted to reiterate this point. We're looking at one of the tabs in source control for Oracle. This is the history tab. The important thing about this is that this history is taken from Subversion. Similarly, if you're using TFS as well, then we populate this tab with the history from Team Foundation Server. So the actual recording of the history is done by the version control system. I guess the difficulty that some of you may have faced in actually source controlling your database changes is the process of actually converting database objects into files and then putting them into source control. Well, this is where source control for Oracle comes in, and which makes it really, really easy. But we can see here from this very quick screenshot here, we've got a little bit of context of how we've ended up at revision 2969 and the kind of things that happened beforehand from different members of our team. The comments are one thing, and wouldn't it be great to be able to see the state of certain objects in the database before they were checked in to source control, and then once they're in source control, and again source control for Oracle, as you'll see when we come to demonstration, enables you to be able to see not just what's changed in terms of the comments that you've added in, but precisely what's changed by doing a side-by-side diff. Again, this will all become more obvious when we come through the demo. So with that in mind, having source control at the heart of development, some of the best practices that certainly we see our customers taking on when they're using our tools and when they're working in a sandboxed environment is getting the latest changes often. If everybody's making changes and then checking those changes into source control becomes the source of truth. That's where everybody, whether you've got 3, 5, 100 people on your development team, as long as there's some place that these changes are going into, and the best place for that is a source control system, the best practice is to get the changes before you then make your own changes, and checking these in small logical units. As you can imagine, if you want to go back and revert to a previous revision, the easiest way to do that and to be able to get up and running quickly is if you have a whole set of changes rather than checking in individual objects. And of course, making sure that the check-in messages are descriptive. So source control fits really into the development. It enables you to have some control over all of these changes. It enables you to be a bit more agile and to experiment more with your database code. Delphix makes that possible, actually makes that really, really easy. The idea that you can give everybody a copy of the database, their own copy of the database, really quickly, let them play with it, let them try and break the application, let them learn by making mistakes. As long as you've got somewhere to record that, then then the whole team will learn, and ultimately you'll end up with a better application at the end of it. Another tool that we've been looking at in demonstration is schema compare for Oracle. Of course, once you've got the changes into source control, you're then going to be looking to deploy them to your testing or UAT environment. If all of the changes have been put into the source control system, that's the obvious place to deploy from, because you know that's going to be up to date as long as everybody's following this practice. So to help reduce errors at deployment, deploy changes from source control. But of course, you do want to double check things before you do that. You don't just want to blindly deploy things. And the tool that we'll look at, schema compare for Oracle, enables you to do a side-by-side diff of source control and your target database before you do the deployment. And we've got a little screenshot here. The comments are one thing, but actually seeing it again in the creation scripts for the objects is great, and you can see exactly what's going to happen should you run this deployment. There's lots of tooling out there for various things, and it always amazes me when we talk to customers, particularly new customers, that before they were using a tool like Schema Compare for Oracle, they were spending an awful lot of time writing update scripts by hand. We use tooling to do lots of things at work and at our leisure, and it's no different really for creating an update script. If you use something like Schema Compare for Oracle, it can do most of the hard work for you. You don't have to let the tool actually do the deployment. The screen we've got here at the moment is the final stage, and the next stage here, you could just copy the script off the clipboard. You could open the script up in something like SQL Developer. You can modify it, make your own changes, but the important thing is here, you don't need to write the update script from scratch by hand. Use something like Schema Compare to save you time. So a quick summary of the benefits of Redgate tools. We spoke a lot about, and certainly when we come to the live demo, we're talking about a sandboxed development environment. If it's something that you're not able to move to, if you can't work in that way, and you're restricted to work in a shared development environment, then our tools will also help you out. Particularly source control for Oracle, one of the features that we've added for source control for Oracle version 2 is the ability for team members to lock objects on the database. And this then gives you some flexibility, gives you the ability to make some changes to objects, and as you're doing so, knowing that your team members can't edit those objects until you've finished making your changes. Of course, when you finish making changes, check them into source control, your object is then unlocked and everybody can then start editing it. So source control for Oracle sits between the database and your existing source control system and makes checking changes in very, very easy, removes manual process. It takes away all of the hard work of trying to create to convert database objects into files. It handles things like data persistence as well. And then Schema Compare for Oracle enables you to compare between the source control system and your target database and script up those changes. What we're going to be looking at today is people who have their own copy of the database, so a sandbox development. Source control for Oracle makes this even easier because you can share your changes through your source control system. So as you're checking changes in, as you're keeping a record and a history of those changes, you can then share them with your other team members. And similarly, one of the things I mentioned earlier about best practices, obviously getting the latest changes before you start work on your own changes. And then once again, Schema Compare for Oracle fits in after this process and compares and deploys the changes between your repository to your database. I'm going to hand back to Kyle now, who's going to start the demonstration off and going to give a quick overview of what we're actually going to be doing in this demonstration.
So we're going to do a live demo now, which is pretty cool because it's going to dovetail Delphix with Redgate tools. So we're going to start out, and I'll start it out, is we're going to create 3 virtual databases with Delphix. So we create a dev1 or dev2 and a trunk. The idea here is that 2 developers will modify dev1 and dev2, and then we'll use the Redgate tools to track those changes and also merge those changes into the trunk database. So graphically, it's going to look something like this. We see Delphix in the bottom left. I'm going to use the Delphix time window, spin up these 3 virtual databases, and then James will take it over and use the Redgate tools to manage the changes and merge those back into the trunk database. So here's the Delphix interface. I'm going to log in here. And what we see here, the most important thing for our demo is in the top left, where my mouse is, there's a black ball with an S in it. This is my source database. These little cards you see flashing across the screen are snapshots that are taken. I can provision virtual databases from a snapshot, or if I want to go down to the second, I can slide the slider open at the top, and then there's a timeline where I can provision a database from anywhere between snapshots. So here I'm just going to take the latest snapshot. On the bottom right, I'm going to click the provision button. To the left of this card, I'm going to say I'm going to provision this back to the machine I'm calling source. I'm going to call the virtual database dev1. At the bottom, I'm not going to use them, but they're pre and post scripts, where I can run scripts to, say, obfuscate data, things like that. There's an advanced button at the bottom where I can change init.org parameters. I'm just going to take the defaults. The next screen, we have groups, where I can set up security groups, which would decide which developers have access to see which of these virtual databases and how much storage they can use. And also, these virtual databases are backed up just like the source databases. This is the technology we use for branching, so I can branch from these virtual databases. Again, I'll just take the defaults, gives me a summary, and I'm finished. And that's all it took. It generally takes about a minute or two to create that virtual database. So that's dev1. I'm going to go ahead and create dev2. Take the defaults just like we did. That's my second clone. And then I'm going to create a trunk virtual database that we can merge the changes from developer 1 and developer 2 into. So we hit provision, name this one trunk. So Delphix has auto-generated these fields with SID, database unique name, and such, but I'm overriding it now because I have a specific name that I want to use. And there we go. I have Delphix creating 3 virtual databases right now. And if we look on the left, we'll be able to see the progress of each of those virtual databases. So dev1 is 54% finished, dev2 is 51% finished, and trunk, which is the one I just did, has just started, is at 13% finished. So for each of these virtual databases and sources, I have policies. This tells Delphix how often do we want to take a snapshot of these sources and virtual databases, and also what kind of retention do we want for down to the second provisioning. We do 2 types of collection. One is a snapshot, which is just the change blocks between snapshots, and then we collect redo logs between the snapshots so that we can provision down to the second. So you can see dev1 is almost finished, 97%. Also, we can create users. So here's the user screen. I can add developers here, and I can set the security policies for which source databases they can see, what actions they can take, how many virtual databases they can create, and I can limit how much storage they take. And for init.orders and such, there's virtual database config templates where I can set up specific templates for specific databases or specific users, limiting, for example, how much SGA they take up or what kind of parameters I want to use on those databases. So dev1 virtual database is complete. Dev2 is 97% complete. And at this point, I'm going to go ahead and pass it back to James, who will use the Redgate tools to track the changes to these databases and merge them into trunk. And by the time James gets to trunk, it'll be finished.
Thank you, Carl. Okay, so what I'm going to simulate here is we've got two developers. They've each got a copy of this new database that Kyle has just spun up. So we've got developer 1 who's using dev 1, developer 2 who's using dev 2. Going to make a couple of changes. We're going to track those changes using source control for Oracle, and then we're going to merge those changes back into the trunk. So at the moment, all three databases, all three virtual databases are identical. I've pre-prepared some stuff, so we've got some very simple changes going on here. But let's open up source control for Oracle. So source control for Oracle has a project here called dev1. Developer 1 has linked that dev1 database to a subversion repository, and that's the important thing here. Source control for Oracle provides the link between the database and your source control repository. Okay, so let's just run this little script here, which is going to make some changes. Let's go back into source control for Oracle. We can see this screen has now changed. So source control for Oracle has picked up that the database and the subversion repository are out of sync. So 5 objects have changed on the database, and these changes are not in subversion yet. As before, important thing to do is to write a descriptive message. I'm just going to obviously make this a little bit clearer for you guys here what's going on here. So this isn't a particularly descriptive message, but this is just simply developer 1 checks in these changes, okay? And I'm going to check in those changes, and you'll see how easy it is now to check changes into your source control repository. It's done already. Those changes are now in. Source control and a database are now in sync. Because I'm doing this on my own, I've obviously had to kind of simulate a couple of things here. So normally each developer would have their own copy of source control for Oracle. I'm trying to do this with a single copy of source control, so I've done that with a project, but please try and imagine that this now is developer number 2, and this is his copy of source control for Oracle. So developer 1 has checked some changes in. Developer 2 is now using the dev2 database that Kyle spun up, but importantly he's also connected to the same subversion repository. We're just going to refresh the screen here. And you can see that this has changed this tab here, which is the Get Latest tab. So those 5 changes that Developer 1 has checked in, Developer 2 can now pick those changes up and apply those changes to the database before he starts work. So let's apply these changes to the database. So source control for Oracle is converting those files back into database objects and then populating the schema on the database. And then just to finish off this simulation, I'm going to run another script here. Developer 2 also wants to make some changes. It's going to automatically refresh. It knows that there are some differences here. So switch back to the check-in screen, and we've got this change here to check into source control. I mentioned earlier that source control by Oracle enables you to look back at the history, and we can see, I've obviously been in quite a lot of demonstrations here, but we can see those changes that were checked in by the first developer. Obviously they would have different names here, but you'd be able to review those before you apply them to the database. I should have gone through that, and you can always see a side-by-side diff of any changes. If we highlight this one here, we can see exactly what's going to change and what the difference is. So we just got a little edit here to the description for this particular view. Okay, so developer 2 checks in changes, and now obviously developer 1 of course could pick up that change if they wanted to and apply it to their database. But at this stage we're pretty happy. We've completed the work that we needed to do. We've fixed the bug, or we've done some testing, and we want to merge those into the third database that Kyle created, which was the trunk database. The tool we're going to use to do that is schema compare for Oracle. And importantly, we're going to deploy those changes directly from source control. You can use schema compare for Oracle to compare and deploy changes between databases. And you can also use it to compare and deploy between a scripts folder. What a scripts folder is, it's as it sounds, it's just a folder of scripts. On my desktop here, which I'm showing, I've got a folder here called widget. The schema that we're working on was the widget dev schema. And I've done an SVN checkout. So very simply, I'm using tools as SVN. I just can go back into the repository, and then I can just do a checkout of this. I've checked it out onto my desktop, and I'm now going to use schema compare to firstly compare the differences between this folder and the target database, and then to create the deployment script. So this is the first screen that we see. As I mentioned before, you can compare databases, you can compare snapshots, and you can compare script folders. Chosen a script folder, that's the folder that I've just shown you now. I'm going to deploy it to, I'm going to compare it to the database and then create a script to deploy those changes. So we've got the trunk database that Carl's just created. We've got the widget dev schema, and we're going to compare those now. This process, incidentally, is identical if you want to compare and deploy changes between databases. Okay. So we've got a number of things here. So the changes that we saw that we're making. So developer 1 made 5 changes. And developer 2 made a change. Here are our 6 changes. We can scroll through all of these, double check that we're happy, that we want to deploy these changes from our source control repository into the trunk. So for the combination of all of the work the 2 developers were doing, it all seems pretty good. We're happy with this. Obviously, this is a very simple example. So we're just going to select all of these objects, and we're going to fire up the deployment wizard. And this is what's really cool. We have 2 options here. We can deploy using schema compare, or we can just create a deployment script. If we wanted to, we could open that up in our IDE afterwards. And we click on next, and we have that deployment script. I mean, it's not a hugely complicated example, but we've got quite a few lines here of SQL, and we didn't have to do anything to generate this. The tool has done it all for us. So at this point, we can decide whether we want to deploy using the tool or open it up and then add a few little changes ourselves, modify it, and then deploy it through the IDE. If I actually go back and use schema compare to do this, just to finish off the demonstration, there are a few things. We can look at a summary, and we can look at any warnings. I can deploy those changes now. This is going to update the database with those new changes, and we can see here that what we've got is 15 identical objects showing us that our target database is now in sync with the Subversion repository, and we can then start testing these changes. And of course, we could use Delphix again to restart this whole process, do some more experimentation, make some more changes. We've got all of the history and the context stored in source control, so we can revert back to stuff as we need to. I'm just going to hand back to Carl now, as he has a few final slides on different alternatives to what we've gone over. But I hope that was useful, and I hope that sort of helped you understand how, once you've created a number of databases, you can manage those and also reduce errors in deploying those changes.
Oops, one sec. Okay, so here's the scenario that we just went over, where we had Dev 1 and Dev 2 using source control, and then using schema compare to put those changes into trunk. But some alternatives, there's a number of alternatives that we could do. So trunk often might be changing. And one of the first steps that a developer might do is merge in any changes from trunk into their copy of the database. And then they modify their database and merge those changes back into trunk. That gets QA'd. And one of the cool things with Delphix is we can easily roll back a virtual database. So if trunk is a virtual database, developer 1 merges in their changes, it gets QA'd and there's a problem, we can roll it back. And then similarly, developer 2 can pull in changes from trunk, modify, and merge back into trunk. And we can make this a little bit more rich and robust. Instead of merging directly into the trunk, we can fork the trunk. So here in this case, developer 1 merges in changes from trunk into his or her copy. They fork trunk, merge their changes into the fork, QA. If it passes, then they merge those changes into the trunk. Similarly, another developer could follow the same path. And all this can be managed by Delphix, Redgate's tools, source control, and schema compare. At Delphix, one of the main questions we get in the development environment is, if each developer has their own copy of the database and they're making changes, how does Delphix merge those changes together? And at Delphix, we're a company that specializes solely in database virtualization. We don't do the merging. So that's what's awesome about dovetailing Delphix with Redgate, because Redgate can handle and control and manage all the source control changes and merging those changes back into a trunk copy. So here's the final wrap-up. Do you want to take this over here, James?
Yeah, thank you, Carl. I'd just like to thank everybody as well for some of the questions that you put in advance. We're going to come to these very shortly. If you've got any questions that you want to put to Carl or myself about our products or the kind of topics and concepts that we've introduced today, then please do enter these now in your question panel. So just as a quick summary to the flow of Delphix and Redgate. So through this demonstration, we created 3 databases using Delphix. That you could see how quickly they were to spin up, but you could obviously create multiple copies. We could create hundreds of copies of the database. Source control for Oracle then sits between the database and your source control repository, whether using Subversion or TFS, and enables you to source control and record those changes easily. And then schema compare enables you to take these changes from the Subversion repository and deploy them back to another copy of the database. Of course, you could use schema compare, as Kyle highlighted in the slide before, to merge changes between databases as you're going along. Best way to find out more information about the tools and how they're going to help you out in your own particular scenario is to check out the web pages. So for Delphix, Delphix.com, you can see an overview of all of the Redgate tools for Oracle at redgate.com/Oracle. If you want to jump straight into the individual product pages for the 2 tools that I've shown you today, then source control for Oracle is simply redgate.com/source control for Oracle, and then schema compare for Oracle, redgate.com/schema compare. I'll include these links in the follow-up email, and when I publish the recording, we'll publish the slides as well, so you will be able to find those links. Okay, so I hope that was useful, and I'd like to open up now to the questions. We've got a couple of questions in already, so thank you again for those, and I'm just going to jump straight into these. Okay, so the first question is for you, Carl, and it's what is the impact on performance of linking and syncing on the source database?
Yeah, that's a good question. So the linking, the initial link or the initial copy of a source database only happens once. When we first connect to that database, it never happens again. And it's a standard database backup. So typically databases are backed up once a week. The Delphix linking process is the same overhead as that standard weekly backup would be. As far as syncing, as far as pulling in the changes are efficient. It's a little different for Oracle and SQL Server. For Oracle, we use a RMAN backup from SCN, and this pulls in only the change blocks since the last backup. So after that initial full copy, for the lifetime of Delphix, would only pull in change blocks. That's quite efficient. One might think of a full copy as being 18-wheelers going down a small road, whereas the incremental backups being motorcycles. It's just the changes being pulled in. For SQL Server, we take that initial backup similarly, but they don't have the equivalent of RMAN backup from FCN, so we just pull in the log changes in the case of SQL Server.
Thank you, Carl. I think that's also answered another question that's in there. If it hasn't, please do let me know, and that's about Delphix using RMAN features. If this hasn't quite answered your question, then please do let me know.
Yeah, Delphix uses RMAN via published APIs from Oracle. So there's nothing that the user of Delphix will see. I can just tell you in the background what you don't see. It's actually calling RMAN APIs.
Thank you. Next question, is it possible to clone only part of the production database, like a set of table spaces or even schemas, for example?
Yeah, this is another interesting question that we get a lot. People might be used to creating clones of a single schema, and then they find out about Delphix, introduced to Delphix, and they ask, well, can I just make a clone of a single schema? For Delphix, the cheapest thing is to make a clone of the entire database, because when we make a clone, there's no data movement. We just point at those data files. And if we actually wanted to drop the database, dropping data takes up space. So the most efficient thing to do is create a clone of the entire database. And if there's data that should be restricted or not accessible, simply lock out those schema accounts so that nobody has access to them.
Okay, there was a follow-up question about transparent encrypted data, so I hope that final point answered that question as well.
Yeah, Delphix handles, the encryption is transparent to us. If you're using Oracle encryption, then the clone databases will be using the same encryption.
Next question, is it possible to download a demo or trial of Delphix?
There's no online download. The next steps to take would be either contacting sales@delphix.com, or you can email me, kyle.haley@delphix.com, and we can set up a WebEx where we would actually take you through a demo of the product.
Thank you.
Although I'll throw out one thing, the demo I did today was on my Mac laptop. It's the code is so portable and storage agnostic and system agnostic that I'm running on an x86 Mac. I set up VirtualBox. My Linux is a virtual machine on my Mac, and Delphix is a virtual machine on my Mac.
Excellent. We're going to follow up to the question before, so I think it just needs a little bit more explanation from you, Carl, if that's okay. And is it possible to unpersonalize customer data from production to non-production during a clone?
Yeah. So the question is, is it possible to unpersonalize, which means to me obfuscate or hide the sensitive data. So there are a lot of tools on the market, and Delphix allows our customers to use whatever tool they're currently using to obfuscate data. So we have pre- and post-provisioning scripts where they can modify data. We find that our customers take one of three paths. Either they have a obfuscated source database that they link Delphix to, so Delphix brings in obfuscated data, or they link us to the production data with the unobfuscated data, and then they obfuscate one virtual data. They create one virtual database, obfuscate that virtual database, and then all developers branch off of that one obfuscated copy. That's the second path. And the third path is simply to create virtual databases, and for each virtual database run whatever obfuscation scripts or software that the company is currently using.
Thanks, Carl. Next question. Will Delphix database virtualization work with a large production database, for example, an Oracle e-business suite with 60,000 plus objects?
Yeah, another good question. We work with any size database. The largest database I personally worked with was 60 terabytes. We work with EBS. We work with SAP. We're actually an endorsed business solution with SAP, which is just as complicated as Oracle EBS. And we've seen huge gains there. One company, KLA Tencor, is an SAP site, and they over doubled the number of development projects on top of SAP that they were able to accomplish after using Delphix.
Next question is, as each virtual database needs its own SGA, is the number of databases you can spin off constrained by memory you have on your machine?
Yeah, another good question. Definitely. The number of virtual databases that we can put on a target host is going to be constrained by the size and number of SGAs we put on that target host. But I'm really excited about this. Some of you might have heard about Oracle 12c and pluggable databases, which drastically reduces the amount of memory each instance is using when that instance is a pluggable database. So this is the best. This is an awesome combination of the best of two worlds, where Delphix eliminates all the storage requirements. Oracle 12c pluggable database will reduce and eliminate much of the memory requirements. And Oracle's quote is that they can put 250 instances in 20 gigabytes of memory. So that just blows the doors wide open for the number of virtual databases I can put on a machine with Oracle 12c.
Yeah, that is extremely exciting. It's something we were talking about the other day. It's very exciting. And just to reiterate a couple of things from the presentation, one thing in particular, for the provision copy, is it correct that the size will be a third of the source?
The only thing that takes up a third of the size of the source is the initial link. Every virtual database after that takes up an extremely minimal amount of storage. Basically, in the case of Oracle, there would be new read logs created, control file, the minimal set, but there would be no extra storage for data files until the data was changed. If somebody started modifying data, that would take up space. So let's give an example. If I have a 9 terabyte database, I take an initial link with Delphix, we compress it down to 3 terabytes, and then I can allocate 10 copies of that database for basically 3 terabytes. So whereas it would take me 90 terabytes of physical copy, it takes me 3 terabytes virtualized.
Yeah, thank you. Okay, so the next question, I think this is quite an interesting question, and thank you for the comment back. So people are pretty impressed with that, Kyle, and I think this next question might impress people further. But so the question here is does Delphix work on Oracle Exadata? I think the real question here is what benefits could an Exadata box bring to the performance of Delphix?
Well, it depends on your company's relationship with Exadata. What we've been hearing is Exadata storage is expensive. People typically want it for their production databases, but they still want to do the development work on the Exadata. So what we can do with Delphix is link to that Exadata database and then create virtual databases back onto the Exadata database. So developers can actually run on the Exadata database, their instance, yet it doesn't take up any storage on the Exadata box. Now there is one limitation, and that is HTC, or hybrid columnar compression. Oracle only supports hybrid columnar compression on Exadata or their ZFS storage appliance. So if one is using HTC, in order to bring it into a virtual database, it has to be uncompressed. But for example, if we're getting 9-to-1 compression with HTC, we're getting 3-to-1 compression on Delphix. So that data is actually 3 times bigger on Delphix than it would have been in Exadata. But I'm not finding that to be much of an issue because setting up HTC takes a lot of planning and decisions and reallocation of data as to what actually goes in the HTC. So for the bulk of work on Exadata, it's an awesome option.
Awesome. Question here, do you need to have block change tracking enabled on the registered Delphix database?
Yeah, that's another great question. It's not required, but it's extremely recommended because with Oracle's block change tracking, when we take that backup from SCN, when it's enabled, we only go and read the change blocks. If it's not enabled, we have to scan the whole database. So it makes a huge difference in the speed and amount of resources required to take that snapshot. And there's block change tracking is extremely simple to set up and basically has no overhead for the database.
Next question here is how a data block changes reconcile between the changes coming from the production stream and the changes performed at the virtual branched database?
That's a great question. That's basically the secret sauce of Delphix. It'd probably take a while to explain that. You can check out my blog, which is kylehailey.com. I have a lot of writing on Delphix. We actually did a webinar with Jonathan Lewis, who spent a good bit of time explaining and diagramming how Delphix works. We had Jonathan Lewis out to our offices for about a week, and we've done 2 webinars with him, and we'll do another one. And Jonathan's done an awesome job of sort of explaining the internals of Delphix to the public.
So we can provide obviously that link with the slides, and we can include it where we publish the video as well on All Things Oracle and on Carl's blog. So the kind of question here that I think I can join together quite nicely. So one of the questions is to do with can the provisions Delphix database be fed from Oracle Golden Gate replication? And the other question is, will flashback technology work on a cloned database? So I wonder if you have any comments on those 2 Oracle features and any other Oracle features that may be affected or things that just simply stay the same.
So one could feed Golden Gate into a virtual database. That wouldn't be an issue. As far as flashback, there's basically 2 flashbacks. There's the classic flashback that's been there since version 9 and is still available through version 12, where flashback is based on undo. That works transparently on an Oracle database and works just fine with virtual databases. It's pretty cool because I could start up a virtual database at the time that I thought I wanted the data from. And if the exact data I want is not there, I could provision another virtual database at a different time, or I could just use the flashback SQL syntax to look for the data I wanted. Now for Total Recall uses archived flashback data, so it has a separate set of files. Those files are not brought over automatically with a virtual database. So it would take some extra setup that's not done by default by Delphix for that to be supported. But one thing really awesome about Delphix, though, is we allow access to temporal data. So what is temporal data? It's when I want to run a query today, I get a response. I'm like, what would happen if I'd run that same query yesterday? Because the database is in a different time. What would the response be? And since it's so easy to spin up virtual databases, I can run a query as it was today, yesterday, a week ago, a month ago, if I have that data in my timeline. Sort of obviates or gets rid of the need for flashback technology. Actually, it's really cool because flashback, the Total Recall actually puts restrictions. You have to decide which tables you want to put it on. It puts restrictions in some of the DDL that you can run on those tables. And with Delphix, it's transparent. There's no restrictions and no overhead.
Another question here. I think we'll take a couple more questions, and then any more questions that you have, you better answer on allthingsoracle.com and obviously directly Carl Hailey.
Let me throw something really quickly out there. We're doing a webinar with Jonathan Lewis next week, and on my blog, khailey.com, there's a forum where we're asking for questions because this is the 3rd and final webinar Delphix is doing with Jonathan, and it's just going to be a Q&A. So We've done a technical presentation. We did results of this week out here, and this last one is just Q&A. So ask all your questions. We'll spend an hour talking about the Delphix part next week.
Thank you. And of course, if you're in San Francisco, 23rd, 24th of September, come over to the roundtable 4 o'clock on Monday, and you can talk to us more about this. So we've got a final question here. Can provisioned up-to-date databases without development updates be used for failover?
Yeah, so the question is, can we fail over to a virtual database? Yes. So the virtual database is typically going to be a few minutes behind production, on the order of 5-10 minutes, because it takes a couple of minutes to provision. We might be a couple of minutes behind in our collection, but you can't fail over. Also, production databases typically have much higher access to I/O throughput, and these virtual databases are running over NFS, which runs over NICs, and your NICs are either typically 1 gigabit NICs or 10 gigabit NICs, and that's going to limit the amount of throughput. So depending on the activity on that production database will depend on how viable or how efficient that failover is. But it's definitely better than nothing. If your production database goes down, you can definitely get access to that production database via virtual database.
There was one more question that's come in. I think we've got time to answer this one. And then, as Carl said, further questions, please do add them to the forum at carlhaley.com. What kind of I/O performance do we get on Delphix, and can we use a cloned database for performance testing?
Definitely. The I/O performance on a virtual database, it all depends on the configuration. It can be much faster than production, or it could be slower than production. It all depends on what kind of I/O subsystem is allocated to Delphix. And there's something really cool about Delphix is Delphix typically has a large cache, and as I mentioned in the presentation, that cache is shared across all the clones. So if I have one source database and 10 clones of it, once one of those source database, once a single clone caches the data, all 10 of those clones will benefit from the cache. And one of the papers on my blog site shows how we basically improve performance dramatically by leveraging that cache, because no longer does data have to go down the disk. You can get it straight from the cache on Delphix. So we can mimic the I/O response time on production given the right configuration.
Fantastic. Thank you, Carl. So I'd just like to thank Carl once again for taking the first part of this presentation. I hope it was really useful for you. I hope you enjoyed the initial talk and a look at the tools. And please do check out delphix.com and redgate.com/oracle to find out more about the products that you've seen today. Thank you, everybody, for your questions, and thank you, as always, for your kind comments. It seems everybody's enjoyed it, so I certainly have.
Awesome, James. Thanks for having me on. I appreciate everybody coming on to listen.
Thank you. And as always, I'll be sending the video out as soon as I've got that up, hopefully in a couple of days. Until then, I hope you have a nice day or a nice evening, depending on where you are in the world. Thank you once again. Thanks, Carl.
Thanks.